In this lesson, we're going to look at solving multi-step equations. Multi-step equations, like the name implies, require more than one, two, sometimes they require 3, 4, even 5 steps to solve. They come in a lot of different varieties, so in this lesson we're going to talk about combining like terms. So let's say you start with a problem like this, where you have 2x plus x plus 12 equals 78. But you can see on the left-hand side of the equal sign, we have two like terms, 2x and x. So what we want to do first, before we do anything else, is we want to combine those two like terms. Well, 2x plus, and we'll put it in here, 1x. You don't always see the 1, but it's there. 1x plus 2x, so that's 3x. So that's 2x's plus 1x. And then you bring down everything else. Don't get lazy and try not to bring everything else down. You want to bring all the work down as you solve the problem. Well, now if you look at this, this looks very similar to some of the two-step problems we were doing in the last lesson. So we can create a roadmap. We'll start by reading it, starting at the x. So we have x. Following orders of operation, it would be x times 3, and then plus 12. So to create the roadmap, we're going to do all of it in reverse and the opposite operations. The opposite of adding 12 is subtracting 12. The opposite of multiplying by 3 is dividing by 3, and that'll take us back to x. So there we go. There's my roadmap. So we'll start by subtracting 12 from both sides. Now we have 3x plus 12 minus 12. Well, the plus 12 and the minus 12 cancel. So we're left with 3x on the left-hand side of the equal sign. And 78 minus 12 is 66. So we've done the first step. Now we'll go to the second step, which is to divide both sides by 3. So I'm dividing both sides by 3. These two, the 3 in the numerator and the 3 in the denominator, cancel out. I'm left with x equals, and 66 divided by 3 is equal to 22. So I've done the next step. And of course, we always want to check our work. So I'm going to take the 22 and plug it back up in here. I have 2 times 22 plus 1 times 22 plus 12. Well, that's equal to 44 plus 22 plus 12, which is equal to 66 plus 12, which is equal to 78. And there's my check. So I know that x plus 12 is the answer. Now let's take a look at a different problem, slightly different, not a whole lot different. In this example, we have the problem 8y plus 16 minus 2y is equal to 46. Note, it's only slightly different than the last problem. In the last problem, the two variable terms were next to each other, but here the two variable terms are separated by the 16. Now, what you want to do, and when you get good at this, this is a step you can eliminate, but think of these two terms as being next to each other. So what I've done is I've rearranged it, and I've taken the entire term, minus 2y, I've moved it in front of the plus 16. So now I've got the two like terms next to each other, and I can go 8y minus 2y is 6y plus 16 equals 46. My roadmap will be y times 6 plus 16. So I've got y times 6 plus 16. Going in reverse order, opposite operations, I would have minus 16 and divide by 6, taking me back to y. So there's my roadmap. I will show subtracting 16 from both sides. 6y plus 16 minus 16, the 16's cancel, so I have 6y equals 30. I've done that step. Now I'll divide both sides by 6. These 6's cancel, leaving me with y equals 5. I've done that step, and it's taken me back to y. Of course, I'm going to check it. So the 5 comes back up on top. I've got 8 times 5 plus 16 minus 2 times 5. That's equal to 40 plus 16 minus 10, which is equal to 56 minus 10, which is equal to 46. Check. So that's how you do solving multi-step equations by combining like terms. In this video, we're going to continue with solving multi-step equations. Last time we talked about like terms, grouping like terms. This time we're going to have grouping symbols. Now in a problem like this, you'll be giving something like -2 parenthesis m minus 4, close the parentheses, is equal to 12. Now there are actually two very viable ways to solve this problem. So I'm actually going to show you two ways to do this. So I'm going to divide the page. We'll rewrite the problem here. -2 times m minus 4 parenthesis equals 12. Now what's different here in this problem is that we do have a set of parentheses with a -2 outside. And you're probably thinking, well, we'll use the distributive property. We'll take the -2 and we will multiply it across the set of parentheses. So we've got -2 times m and -2 times -4 is equal to 12. So we have -2m. Now -2, if you look at this, it's a -2 times a -4. A negative times a negative is a plus, or positive 8 is equal to 12. Now we're back to a two-step equation where you could use the road map. I think what I'll do is I'll just go ahead and solve this problem and let you do the road map in your work. To continue, I would subtract 8 from both sides. I have -2m plus 8 minus 8. Well, the plus 8 and the minus 8 cancel, so I have -2m is equal to, and 12 minus 8 is 4. And to finish this, since it's -2 times m, the opposite of multiplying by -2 is to divide by -2. And so these 2's cancel, leave me with m. M is equal to, and a positive 4 divided by a -2 is -2. Now, that's one way to solve this problem. Another way, and I'll rewrite the whole problem, is to recognize that this is -2 times this quantity of m minus 4. So rather than distribute, I also have the option of beginning this problem by dividing the entire thing on both sides by -2. And if you look, that gives me a -2 in the numerator and a -2 in the denominator. Those two cancel each other out, leaving me just m minus 4 is equal to, and 12 divided by -2 is -6. Now I've got m minus 4, and the opposite of subtracting 4 is to add 4 to both sides. Now m minus 4 plus 4, these cancel. I'm left with m is equal to -2. -6 plus 4 is -2. But if you notice, either way is going to give me the same answer. Now, of course, if I were being complete, I would take the time to check these by taking the -2, plugging it back up in for m, or take the -2 and plugging it back up in for m. But either way, I'm going to get the right answer. So I'll leave the checking up to you. Now here's another problem. It's going to add one more step, so I guess it's a little more complicated. But it's 15 is equal to -3, open up a set of parentheses, x minus 1, close the parentheses, plus 9. Well, you can see how this is a little bit different. For one, my variable term is now on the right-hand side of the equal sign, and I've got this plus 9. This is a great opportunity to use your roadmap for something a little more complicated. But again, process is the same. I'm going to start by starting with x. It's x minus 1. once I've subtracted 1, I have to multiply by negative 3. Once I've multiplied by negative 3, I add the 9. Now, going backwards, I'm going to do the opposite operations. The opposite of adding 9 is subtracting 9. Opposite of multiplying by negative 3 is dividing by negative 3. And the opposite of subtracting 1 is adding 1. And that'll get me back to x. So there you have it. There's your roadmap. We'll start by subtracting 9 from both sides. (15) minus 9 is 6, equals, and I have the negative 3 times the x minus 1, but the positive 9 and the negative 9 cancel out. So I've done that step. Now my roadmap says to divide by negative 3. So I'm going to divide both sides by negative 3. And if you look, 6 divided by negative 3 is negative 2. A positive divided by a negative is a negative, equals. Now this is interesting because I've got a negative 3 in the numerator and a negative 3 in the denominator. And those two cancel each other out, leaving me just x minus 1. So I've done that step. Now my roadmap tells me to add 1 to both sides. So I'll add 1 here and add 1 here. Negative 2 plus 1 is negative 1 is equal to, and x minus 1 plus 1, the negative 1 and the positive 1 cancel out, x. So negative 1 is equal to x. If you like, x is equal to negative 1. Of course, to be thorough, you want to take that negative 1, plug it back up into your original problem, and make sure it works. And again, I'm going to leave that up to you. Hi, in this video we're going to continue with our multi-step equations. This is part 3, and this is when we're going to introduce fractions. So let's take a look at an example. Let's say you had 2x over 3, and you wanted to add x over 2, and know that it was equal to 7. There are actually two ways to do this problem. I'm going to show you both ways and let you decide which one you like best. So I'm going to divide the page, and we'll do the first one over here on the left-hand side. I'm going to start by rewriting the equation. Now I notice that I've got two fractions that need to be added together. But to add two fractions, they have to have the same denominator. And one way to approach this is to ask yourselves, what would be the least common denominator? And if you look at 3 and 2, it's fairly obvious to see that the least common denominator is 6. So we're going to have to multiply this fraction by 2 over 2 and multiply this fraction by 3 over 3. So I'm going to rewrite the equation showing 2 over 2 times 2x over 3 plus 3 over 3 times x over 2 equal to 7. Now when I go to multiply these, I just multiply the numerators together. 2 times 2x, that's 4x, over, and 2 times 3 is 6. Plus, now I do it to these two fractions. 3 times x is 3x, over, and 3 times 2 is 6, equals 7. Now I can combine these two fractions because they have the same denominator. So I get 4x plus 3x over 6 is equal to 7. Well, with these two being like terms, I can combine those as 7x over 6 equal to 7. Now a real slick way to get rid of the 7 and the 6 and to isolate the x is to multiply by the reciprocal of 7 over 6. So I'm going to take this and multiply both sides by 6 over 7. And if you look, that gives me a 6 in the numerator and a 6 in the denominator. Those cancel. A 7 in the numerator and a 7 in the denominator, and those cancel. And that leaves me with just x on the left-hand side of the equal sign. So x is equal to, now come over here on the right-hand side of the equal sign. If you rewrite the 7 as 7 over 1, you can see you're multiplying two fractions. Even better, you have a 7 in the numerator and a 7 in the denominator. Those cancel, and you're left with 6 over 1, or just 6. Now, of course, to be thorough, you would want to take that 6 and plug it back in into the original equation and make sure it worked. I'm going to leave the checking to you, because what I want to show you now is a second way of doing this problem. I'll rewrite it. 2x over 3 plus x over 2 is equal to 7. Now this time what I'm going to do is I'm going to think of the least common multiple of 3 and 2. And again, it's just like the denominator. It's going to be 6. But what I'm going to do is I'm going to multiply the entire equation on the left-hand side by 6 and on the right-hand side by 6. And what I'm going to do is distribute the 6 across the parentheses. So now I've got 6 times 2x over 3 plus 6 times x over 2 is equal to, and 7 times 6 is 42. We get to do a little canceling because I have a 3 in the denominator and a 6 in the numerator. So that 3 will go into that 6 2 times. And this side, I have a 2 in the denominator and a 6 in the numerator. Well, that 2 will go into the 6 3 times. So now I've got 2 times 2x. That gives me 4x plus, and 3 times x is 3x, equals 42. I have two like terms, 4x and 3x, which I can combine to be 7x, is equal to 42. And now, if it's 7 times x, the opposite operation would be to divide. So I'll divide both sides by 7. I have a 7 in the numerator and a 7 in the denominator. Those cancel, and I have just x is equal to 42 divided by 7 is 6. You can see I got the same answer both ways, and that's important. You don't want to get two different answers. Now you have the two options when you're doing a problem like this. You can go for the common denominator like we did on the left, or you can multiply by the least common multiple, which we did on the right. But don't forget to check your answers. I've got one more problem I want to show you in the multi-step equations category. So we're going to call this part 4. And the reason I want to show you this problem is it's a little more complicated. But I don't want complicated to scare you away. As long as you're comfortable with things like the roadmap, showing all your work, it shouldn't be too much of a problem. You'll notice we have one variable. We're taking it, we're multiplying it by -4. Then we're subtracting 3. And then we're dividing by 6. This is a great time to use a roadmap. So I'm going to start by saying x. Following orders of operation, I would multiply that by -4. Once I had multiplied by -4, I would subtract 3. And then once I had subtracted 3, I would divide this whole side by 6. So we're going to do it in reverse order, and we're going to do the opposite operations. The opposite of dividing by 6 is multiplying by 6. The opposite of subtracting 3 is adding 3. And the opposite of multiplying by -4 is dividing by -4. And that'll take us back to x. So here's my roadmap. It tells me to start by multiplying both sides by 6. So I'll come over here and I'll multiply both sides by 6. And of course I'm going to think of this 6 as 6 over 1. I have a 6 in the numerator to cancel with a 6 in the denominator. And that leaves me -4x minus 3 over 1. But again, I don't have to put the over 1. So I've got -4x minus 3 is equal to -54. So I've done that step. Now my roadmap says to add 3 to both sides. So I'll add 3 and add 3. Now, -4x minus 3 plus 3, the minus 3 and the plus 3 cancel, and I'm left with -4x is equal to -54 plus 3 is -51. So I've done that. And now it tells me to divide both sides by -4. Divide by -4, divide by -4. -4 over -4 cancel, and I'm left with x. So x is equal to -51 divided by 4. Well, maybe you don't recognize quickly, does 4 go into 51? So don't be afraid to go onto the side and go 4 into 51. 4 goes into 5 once, so we put a 4 down. We subtract, we get 11. Now 4 will go into 11 2 times, and that's 8. Subtract 8 from 11, you get 3. So we actually have a remainder in this problem. So of 3 over 4. There's my answer, except I have to remember this was a negative. So x is equal to negative 12 and 3/4. Don't be afraid of fractions. It doesn't mean you're doing anything wrong. It just means that you're going to have to be a little more careful and double check that you think you do have the right answer.